Hello everyone, I'm Blake, and today I'll be demonstrating our fish recognition software that Josephine and I built. So as you can see, we're using the Keras sequential model from TensorFlow, and we're importing all of our data in from Google Colab, or using Google Colab through our drives. I assign a file path here to where the fish data is, and set a batch size of 32. Whoops, I accidentally edited that. We set a batch size of 32, and we initialize the image height and image width. Then we grab our training data and our validation data, and we set the validation split to 0.1 or to 10% of our data, which in this case is 900 samples. Uh, we have a batch size of 32, which means all of our data gets grouped up into 32 group clusters, and we initialize all of the height and widths of our images to all be the same size. Then right here, I take the top 8,000 images and I split them up into 10 groups. The reason why I do this is because if I try to load in all of my data, Google Colab crashes due to over allocation of RAM. And I noticed a lot of you were kind of impressed with our original accuracy. I just want to give some clarifications as to why that is. So first, we're going to take a quick look at the data set that we've been using. So if you look in here under fish data set, we have our 9 types of fish, including shrimp, even though they're not really fish, they've been included anyways. And then we can see that all of the fish have the same type of background, and it's just rotated about. Uh, and this applies to all of our fish samples. So because most of the fish that have been chosen in this data set have a unique shape, it allows the software or allows our model to be a lot more accurate than it would be if we just grabbed images of fish randomly from online. And also, the fish have pretty unique colors to them, with the trout and black sea sprat probably being the closest in terms of color. But then they have a fairly different shape. As you can see, the trout are quite big and bulky, very fat and oval shaped, almost like big eggs. And then the sea sprats have this flat back here and then a rounded bottom or a rounded belly, which makes it quite easy for our model to differentiate between the two. The other thing that's really helping us out is just the sheer quantity of data we have. Uh, as I said, we're taking in the top 8,000 uh, images, and each image offers a ton of data for our algorithm to use in order to better itself. And speaking of our model, here's how we built it. So we've rescaled all of the inputs of the data uh, so that no value from our image was above 1. And then we used several convolution layers, two-dimensional convolution layers. The first one being only 16, a size of 16, that would be 4 and 4. And then the second one being 32, third 64, and then at the end we have a dense neural network, and under Keras's model system, a dense neural network is just a standard multi-connected neural network. So all the nodes in one column are attached to all the nodes in the previous and the front columns, whereas the convolution nodes kind of just edit the image that we're currently working with. And because of this, 128 nodes in our dense layer, we end up with a pretty bulky model. Uh, and then we compile the model using the Keras compilation system with the Atom optimizer. And we're shooting for our metric of accuracy. And then we print out a quick model summary here. And so as you can see in here, here's all of our layers. We do a rescaling of everything, couple convolution layers, and then our dense layers. And this is the total number of trainable parameters in our model. 32,915,753 trainable parameters. That is a sheer magnitude of parameters that just really allows our model to dig its teeth into each image so that we can really quickly learn what we're trying to get out of this. And you can see up here, we're using 8,100 files for training, though technically, because of how I've split the data up here, we're not using that last 100. And we've got 9,000 files for validation. And then right here is the simple training method using the Keras model.fit, throwing in our training set validation data, and then appending that to a history. And then we save our model after it's finished running its training. And then for our training, the first epoch, which is this one I've highlighted right here, our accuracy has gone down in terms of validation accuracy from our original model. This is because I had to change some of the parameters inside our model. Originally, I had these set to 1, 2, 4, and 8 because I was having a RAM crash due to an overallocation, and I couldn't quite figure out where. And I just assumed that it was the 32 million parameters that we had, and it turns out it wasn't. So our accuracy's changed up a little bit, and while our initial epoch validation accuracy has gone down, our final epoch, epoch 10, down here, now has a validation accuracy of 83.67%. I want to thank all of you for watching our demo. I hope you have a wonderful night.